All right, so today we're talking about lesson 6.1, similar polygons. What is a similar polygon? Polygons are similar if all their corresponding angles are congruent, sorry, that should say are congruent, and the length of all corresponding sides are in proportion. So they have the same shape, but they're not the same size. Um, Another really super important thing you need to know is scale factor. That is the ratio of the lengths of two corresponding sides of two similar polygons. The scale factor has to be the same for all three or four or five or however many sides the polygon has. All the sides must have the same scale factor. So let's check to make sure that these two triangles have the same scale factor. So if I look at the angles, we notice that angle A is congruent to angle B, angle E is congruent to angle B, and C is congruent to angle F. So now I can check the scale factor. I'm first going to take a look at AB, and AB corresponds with DE, right? So I'm just putting this here as a placeholder because we're going to plug in the numbers that we have, right? AB is 4, and DE is 2. 4 over 2 is 2 over 1. All right, I need to check all the other remaining sides. So the next side, I'm going to pick BC. BC corresponds with EF. BC is 6. EF is 3. 6 over 3 is 2 over 1. All right, one more side to go before I can say for sure that these two triangles are similar. Last one. So the last side is AC over DF. AC is 8. DF is 4. 8 over 4 is 2. So the scale factor on all three sides is 2 over 1, 2 to 1. So I can say the triangle ABC is similar. So, okay, similar is different than congruent, right? It just has that little squiggly. Similar to triangle. And I want to make sure I name the second triangle in the correct order. So since I started with A, I'm going to start with D, E, F. Okay? Order matters. You want to make sure that angle A corresponds to D, and D corresponds to E, and C corresponds to F. All right, beautiful. All right, let's look at another example. Oh, I'm sorry. Here's something else I wanted to tell you about. The median of a triangle is a segment from the vertex to the midpoint of the opposite side. So let's just say that this base is 10. The median is going to come from the vertex, which is the top of the triangle, and cut the base in two congruent segments, right? Each would be 5 and 5. That's what a median does, right? It comes from the vertex and hits the middle of the opposite side. Splits it right in half. Another thing I want to talk about was altitude. Altitude is the perpendicular segment from the vertex. So it's similar to a median. It comes from the vertex to the opposite side, but it's perpendicular. So it is essentially the height of the triangle, but know that it's perpendicular here, right? It makes a right angle. In this triangle, now it doesn't look like it because it looks like it's on a slant, but that would be the altitude. It is perpendicular to the opposite side from the vertex. Okay? So this is also known, aka the height of the triangle. All right. Now we can look at some more examples. So first we're going to determine whether the figures are similar, and if so, we're going to write a similarity statement and write the scale and find the scale factor. So first I'm going to note that angle H corresponds to angle M, angle L corresponds to angle D, angle F corresponds to angle K, and angle N corresponds to J. And what I mean, they're congruent, right? The angles remain the same measure. It's the length of the sides that change when an image is bigger or smaller than any other figure. All right, so let's check the scale factor. So first we're going to do FG. That corresponds to KL. And then we'll plug in the numbers. We have 8 over 6. 8 over 6 is 4 over 3. Then we'll go FJ. That corresponds to KN. When we plug in the numbers, we have 12 over 9. That reduces to 4 over 3. All right, we'll just keep working our way around this figure. So we're at JH. That corresponds to NM. And that is 20 over 15. 20 over 15 is 4 over 3. I think we have a common factor of 5. And the last but not least, GH corresponds to LM, 16 over 12. And we have a common factor of 4, and it reduces to 4 over 3. Please be sure that you're reducing so that you're getting the proper scale factor, okay? So all 4 sides of these figures have the same scale factor. So the scale factor is in fact 4 over 3. And now let's write our similarity statement. So we'll start with the first shape. We'll say F, J, H, G is similar. Now it's really important we name the second figure lining up the congruent angles, right? F. So we would start with K, N, M, L. So F, J, H, G is similar to K, N, M, L. Okay. And the scale factor was 4/3. 4 over 3. However you want to say. All right, triangle ABC is similar to triangle DEF. We're going to find the values of X and Y, find the scale factor of triangle ABC to DEF, and find the perimeter of each triangle. Okay, first off, let's start with the scale factor because that's really the first thing we want to find, okay? I see that AB has a value of 10. There's no variable here, and that's what I need. I needed to have an exact value. And I see DE has a value of 5. For the scale factor, if I put AB over DE, that is 10 over 5, which is 2 over 1. That is the scale factor. Scale factor. It is hard to write. Okay. 2 over 1 is the scale factor. Now I'm going to use that scale factor to solve for X and to solve for Y. So first I'm going to start with my scale factor, right? And I'm going to make a proportion. I am first looking for X. Okay, notice that ABC triangle is bigger than DEF, right? It's 2 times bigger. So I'm going to put this X plus 3 in the numerator. And that corresponds to DF, right? AC corresponds to DF. So I'm going to put 3 down here, and then I'm going to cross multiply. So I'm going to cross multiply. 6 is equal to X plus 3. Subtract 3 from both sides, and I get X is equal to 3. When we plug that in, we get 6. Okay? Now, I'm going to solve for Y. I'm still going to use that scale factor to set up my proportion, right? And Y, the term with Y is on the side CD. So CD, Y minus 5, corresponds to FE, which is 4. We're going to cross multiply again. And we get 8 is equal to Y minus 5. When I add 5 to both sides, I get Y is equal to 13. Okay, if I plug in 13 here, I get 8. All right, now it said find the perimeter. Remember, the perimeter is the measure of the outside. So if I just add up these sides, I'll have the perimeter. 6 plus 8 is 14, plus 10 is 24. Now we know that this triangle is twice as big, so if you're thinking that, you're like, oh, the smaller triangle is 12. Let's just see if you're right. 3 plus 5 is 8, plus 4 is 12. It is. So that is the perimeter of the smaller triangle. Okay, so let's take a look at this quadrilateral. MNOP is similar to quadrilateral QRST. Find the value of x and y. All right, first off, I'm just going to write my similarity statement, right? MNOP is similar to QRST. Okay, now first I want to find my scale factor. So I'm going to look for sides that have a number without a variable. So I have MP. MP corresponds to QT. QT has an 8, right? So I'm going to start with my scale factor. All right, so I said MP corresponds to QT. So MP is 12. And QT is 8. So 12 over 8 reduces to 3 over 2. So that's the scale factor, okay? 3 over 2. That's going to help us set up a proportion so we can solve for the remaining unknown sides, okay? So I'm going to start with the scale factor, 3 over 2. I'm looking for x. So x here with the 3, right? Obviously, you can see that this quadrilateral MNOP is larger than QRST, and 3 is larger than 2, and that's why x is going to go in the numerator. The side that corresponds with MN is QR, and QR is 10. Right, then we're going to cross multiply. 2x is equal to 30. Divide both sides by 2, and I get x is equal to 15. Okay, so we know that this is 15 here. I'm going to do the same thing for, oh, actually, I can't do the same thing for y because that is talking about an angle, okay? Remember, the angles don't get bigger or smaller depending on the size of the shape. They always remain the same measure in degrees. So a little fun fact you need to know is the interior sum of a quadrilateral is 360 degrees, okay? So remember that this box means that that's 90 degrees. So now we're going to say 115 plus 62 plus y plus 10 plus 90 is all equal to 360. Okay, I'm going to combine like terms, and I'm going to get down to right, all these terms when I bring them together, right? So you should have y plus 277 is equal to 360. Subtract 277 and you get y is equal to 84. All right, that just means that this measure here is 93 degrees. Okay, beautiful. And that's it. We answered all the questions, right? We found x, we found y. We're amazing. We're killing it. We know the scale factor. That's great. Okay, so let's take a look. What else we have? All right, so now we have corresponding lengths in similar polygons. If two polygons are similar, right? Here's our statement. Triangle TPR is similar to triangle XPZ. In the polygon is equal to the scale factor of the similar polygons. Let's first find the scale factor. So we're going to use our corresponding sides. I see on the ends here, or the base of our triangles that are on the side, right? TR corresponds to XZ. So we're going to say 12 over 16. And we always want to make sure we reduce. 12 over 16 reduces to 3. Oh my goodness gracious, that was pretty good. 3 over 4. That is our scale factor, okay? We're going to use that to solve for x. So we're going to start with our scale factor, 3 over 4. And now x is the height or the altitude of the smaller triangle, right? 3 is smaller than 4, so it's going to go in the numerator. And 20 is going to go in the denominator because that's the corresponding altitude of the bigger triangle. Cross multiply, 4 times x, 4x. 3 times 20 is 60. Divide both sides by 4. And I get x is equal to 15. Fantastic. Okay, so now we know that the height of this triangle is 15. All right, so it's really important that you know how to find the scale factor and that you reduce it and then use that to set up a proportion to solve any missing size or height. All right, here's your assignment for tonight, number 26, page 362, 363, number 3, 4, 7 to 13, and 19 to 25. And if you work smart, you might not even have homework tonight if you get it done in class. All right, see you later.